Okay, well, good morning, good afternoon, good evening to everybody. We are into section 6.5, and this is video A, the first video of the series in 6.5. 6.5 talks about, again, factoring trinomials. We're going to talk about two specific situations of trinomials, difference of squares, and actually be a binomial. Binomial will be a difference of squares. Perfect square trinomials is something else that we'll have to take a look at. And the reason we're doing factoring and spending so much time factoring is that when we get to Math 141, then we'll need to be able to factor things fairly easy, fairly quickly, fairly fluently, fairly comfortably, without having to think about which method do I use, is this a perfect square, I don't remember. You don't want to have to be stumbling on the factoring when you're dealing with other things. So we're going to deal with factoring a little bit today. We're going to talk about difference of squares in this video and then perfect square trinomials in the next video. So let's get to it. And we'll talk about difference of squares and perfect square trinomials. Difference of squares is going to go on today. So we're going to talk about difference of squares. Hang on a second. Difference of squares in this video. Difference of squares trinomials, it's a special trinomial of the form a squared minus b squared. And that a, we'll find out, can be a couple different things. Could be variables, could be numbers. Same thing with the b. B could be variables, could be numbers, but they both have to, a squared has to be a squared term. So we have to find a square root of it. So we can put the square root down here and the square root down here. Same thing for b squared. Has to be a perfect square, in other words, numbers and variables, and there has to be subtraction between them. So this has to be a perfect square. Here's the criteria, I guess, for a perfect square trinomial. Maybe something for your cheat sheet or your study guide. First term has to be a perfect square, and maybe we could rewrite it as a squared, because that a could be a base of anything. Could be a number, could be a variable or a letter. But the whole thing has to be squared. Same thing for b. We're going to rewrite that as b squared, and our base has to be squared for that second term. And then this terms have to be separated by subtraction. So we'll find that there's the three criteria that we have. If we do find those three criteria together, a square, separated by subtraction, then we can find that our factor is here. And the reason for that is if remember in chapter 6 we're factoring. We're going from a trinomial or a binomial to the factors. In chapter 5 we learned that a plus b times a minus b, when you FOIL it out, we can get first terms would be a squared, outside terms are minus ab, inside terms are plus ab, and again it'd be b times a, but it would be the same thing as plus ab. And the last term would be minus b times positive b times negative b would be negative b squared, and then we have to combine the like terms. Minus ab plus ab b minus 1 plus 1 would be 0, so these would be canceling out, and we would get to a squared minus b squared as our final product. And so this makes us realize that when we take this and we FOIL it out, we get these two factors combined together when multiplied to give us this product. So when you see this product, there's our factorization. Let's go through some examples. And I guess before we get to the examples, we're going to talk about recognizing perfect squares. We're going to look for perfect square numbers. And really on page 440, there's a list of perfect square numbers. In other words, 1 squared equals 1. 2 squared equals 2 times 2 is 4. 3 squared equals 3 times 3 is 9, etc. 16, 25, 36, 49, 64. Did I skip anything? 7, 8, 9, 81, 100, ... And I'd recommend looking at page 440. It's definitely a nice to know. And it might even be more than a nice to know. It might be even a need to know, especially for this section. It might be a need to know. So I would definitely take a look at page 440 and really be comfortable recognizing these perfect squares, 1 and 4 and 9 and 16 and 25 and 36, etc. Probably all the way up to 15 times 15 is 225, something like that. So keep going on. Recognize these perfect square numbers because we're going to need them, especially for recognizing difference of squares and perfect square trinomials. It also, so that's as far as numbers go. Here's some numbers that we will need to know. As far as the variables go, we will need to know that if an exponent is even on a factor, then that is a perfect square, or on a term. So if I take a look at this, x squared, that I know is x squared. So here's my base, and it's squared. X to the fourth is also a perfect square. We can rewrite x to the fourth as x squared squared. And right there is our perfect square, and here's our base. Remember, if we're factoring a squared minus b squared, we're going to have to look for the a as well, and not only in terms of numbers, but also in terms of whatever variables are present as well. X to the sixth can be rewritten as x to the third squared, and that means that this is our base, and it's squared. So this is a perfect square, kind of rewritten, could be rewritten as this. So we'll need to keep that in mind as well. Anytime that a variable has an exponent that's even, it's a perfect square and can be rewritten in terms of a perfect square. Alright, keep that in mind. Probably a need to know as well for that. Let's factor the difference of squares. So I'm giving you the fact that this is a difference of squares. Here's a y squared minus 25. And you know what? I'm going to just rewrite this as y squared, because up here it's the same thing as writing this x squared as x as a base squared. So here's my base. There's my squared minus, what's 25? 25 is a perfect square, and in fact I gave you the fact that it's a difference of squares. But 25 is a perfect square, so we can rewrite that as 5 squared. And remember, if we've got a squared minus b squared, that factors to a minus b times a plus b. So we have to really remember that we're writing the a's here and we're writing the b's here. So we have to find out what that square root is of this term. So the square root of this, 25, is 5. It's squared, so our base is here, b is right here, a is right there, and we can rewrite this simply as a. It'd be a minus b, a plus b. So here's our a is y, minus b, b is 5, times y plus 5, and we're done. Y minus 5, y plus 5. We can FOIL it out to double check, but that's our factorization. And I'm going to go through, these steps as we go through, just to make sure that we understand that this y squared is a y squared, and that's our base, and the base goes over here and here. 25 is 5 squared, and the 5 is our base. The b goes right there and right there. And because it's separated by subtraction, we can do this. Alright, here's again another difference of squares, 49s squared minus 4t squared to the fourth. Let's rewrite that as 49, let's see, can we rewrite this term as our a squared? What would be that a squared? It would be square root of 49 would be 7, square root of s squared is s, and the whole thing squared would give us 7s, the whole thing squared gives us 49s squared, so that's okay. Minus 4t to the fourth. Now keep in mind that 4 only works, the fourth power only works on the t as our base, so that we've got to find the square root of 4 is 2. Square root of t to the fourth is t squared, and this is our kind of rewritten example. So 49s squared can be rewritten as 7s, everything squared. We've got a subtraction, so that helps us figure out that we've got difference of squares. In fact, we were given that it's a difference of squares, but we have to go through our thought process as well. 4t to the fourth power is 2t squared, all squared, so 2t squared is our base. Now we have to rewrite this as a minus b, a plus b. Here's our a is 7s, so we have write 7s minus 2t squared times 7s plus 2t squared. So there's our two examples that we've got. We've got a third example here, and I'm going to say, do me a favor, take a step back, pause the video when I ask you to, and say, can I factor this? I'm giving you that these are difference of squares, because the instructions say factor these difference of squares. But how can we make 18 into a difference of squares? and 2z into a difference of squares, because these are not, 2 is not a perfect square, 18 is not a perfect square number, so how do we do that? So pause the video, see what you can do with that, and then we'll come back and get together. Alright, now that we've done that, we've paused the video, you've taken a look at it, and hopefully you've gotten the idea that we need to kind of make our life simple. Remember when we had we had to factor ax squared plus bx plus c, and we had to go through our thought process of, number one, factoring out a negative number, making sure that we've got descending order, making sure that we've got greatest common factor factored out. Well, for this one, we have to really factor out a greatest common factor. So from here, we can factor out a greatest common factor. There's a z here and a z here, so we can put a z over here as a greatest common factor. And there's also a 2 that's shared by these two factors. So we can factor out a 2z, and what's left over, 18w squared z divided by 2z gives me 9w squared. And that looks like a perfect factor, perfect square, because 9 is a perfect square, w squared is a perfect square. What do we have left as well? We've got minus 2z divided by 2z is minus 1. We've got to keep that place marker, because when we do the distribution, 2z times 9w squared gives me 18w squared z. Okay, that's a correct factorization, or a correct factorization for these two. For this one, 2z times minus 1 gives me a minus 2z. Okay, great. So we've factored correctly our greatest common factor. And now, how about 9w squared? 9w squared can be rewritten. I'm going to rewrite this as well, 2z, because remember, just like in our factoring trinomials, we've got to make sure that if we're factoring this big trinomial, this black written trinomial, we've got to rewrite every factor that comes out. So 2z is part of the factorization, so that keeps going down to the end until we finally get it done. 9w squared, I'm going to rewrite that as 3w all squared, and then minus 1 squared. Just to say that, you know what, let's follow the thought process and say, factor this out, and then 9w squared is rewritten as 3w squared. 3w is our base. The 1 can be rewritten as 1 squared, but we get the idea that it's a perfect square anyway. So now let's rewrite this as 2z times, it'd be a minus b, a plus b. Here's our a, here's our b. A is 3w, b is 1, so we rewrite 3w minus 1, 3w plus 1, and that should be our factorization. So there's our factorization. Hopefully you got that one. Alright. A little bit tricky because we had to factor out a greatest common factor, but keep that in mind anytime you see any kind of factorization question. You got to factor out a negative 1 possibly. You got to make sure it's in descending order, and then factor out a greatest common factor. Always look to factor out a greatest common factor if you're given a factorization question. Alright, 2 more questions, 2 more slides, I guess. We've got a difference of squares. This talks about difference of squares, and that was pretty straightforward to factor. You kind of rewrite a squared as a base squared, and the same thing with subtracting. You got to have a subtraction between them, and then b squared could be rewritten as b quantity squared. So that was pretty straightforward, I think. Can we factor a sum of squares? Is that possible? The short answer is no. So a squared plus b squared is not factorable. So if there's a subtraction sign there, it's factorable as the difference of squares. If there's a sum there, a plus sign, that is not factorable because it's a plus sign. The difference of squares is factorable. Sum of squares, not factorable. I guess that is unless a squared and b squared do have a common factor. Then it could be factorable only by pulling out that greatest common factor. But otherwise, a squared plus b squared, not factorable. So with this fact now in mind, that a squared plus b squared not factorable, let's factor these. Can we factor them? Pause the video and factor this. Factor a, factor b, and factor c. And tell me what your answers are. And in fact, let's see. Well, pause the video and we'll go from there. Alright, so now that we paused the video and we've said now we can or can't factor these, we're going to take a look at this and say, is it factorable? We've got 2 terms. Perfect square here, p squared is a perfect square, 9 is a perfect square, it's 3 squared. It's separated by subtraction, so difference of squares is factorable. In fact, I'm going to write this as my base, minus my base of 3 squared. P squared minus 3 squared gives me a minus b. Or sorry, a squared minus b squared. So here's our a is p. B is 3, so we have to rewrite this as p minus 3, p plus 3. And keep in mind, too, that you could write the p plus 3 first and the p minus 3 second. Multiplication is commutable that way. So you can write, if I'm multiplying 2 times 3 is 6, but 3 times 2 is also 6. So either way you write that, that's okay. All right. Let's see. Can we factor this one here? Can we factor it? I don't know. Let's take a look at it. P squared is a perfect square. 9 is a perfect square. We've got addition here, though. Subtraction, because difference of squares is factorable. That's a is factorable. Addition of squares means that this is not factorable. Not factorable. We could, I guess, take a look and see, does p squared and 9 have a common factor? No, it doesn't, so that definitely means that it's not factorable. So b is not factorable. And let's see, for c, we'd take a look at this and say, well, w to the 4th power minus 81. Well, 81 is a perfect square number, and we can rewrite that as 9. You know what, I'm going to switch to red. I'm going to switch to blue, sorry. Here's 9 squared. We've got a subtraction here. W to the 4th power is a perfect square because to the 4th power is an even power, and that means that we can rewrite this as w squared squared. Anything with an even power is a perfect square. So w to the 4th, because 4 is even, means it's a perfect square, rewritten as this. So here's our a term, here's our b term, and we now rewrite as a minus b, a plus b. So here's a w squared minus 9 times w squared plus 9. And we're done, right? Or not. Anytime you factor something like this, take a look at, especially with a w squared left over, here's a w squared, take a look at this and say, can we factor that one? Let's take a look at factoring this. Well, you know what, that is a perfect square, or sorry, it's a difference of squares, isn't it? Because w squared is a perfect square, 9 is a perfect square, so we could rewrite this as w minus 3, w plus 3, and then rewrite the w squared plus 9 as w squared plus 9, because w squared plus 9 is a sum of squares. Sum of squares is not factorable unless w squared and 9 share a common factor, but they don't. So here is our complete factorization right there. W minus 3, w plus 3, w squared plus 9. All right, last one. Here's a question for you, and I'm going to leave this as homework. I'm going to say, do this as homework, and say, keep this in mind, that when we got down here as kind of a factor, we got a w squared minus 9, and we could factor this. So don't just stop here and say, oh, I'm done. W squared minus 9 is factorable again. So with that in mind, go up here, and this will be your homework. So make sure you take notes. Add this to your homework, or I guess do the homework as this question. Factor by grouping. Remember, with factoring by grouping, we're taking the first two terms and grouping those together. We are going to take the second two terms and group those together and see what factorization we can get. We'll factor something out of the red, we'll factor something out of the green, and then with the red we might have something that's similar to this page back here, question number C. So with that in mind, do the homework, take a picture of your homework, send it in, as always. Take a picture of your notes, take a picture of your homework, make sure that it's all included, send it into my Dropbox, and we'll go from there. And I'll see you soon.